Hello everyone, in this video we're going to talk about inverse trig functions. We had already discussed inverse sine function. We graphed sine with its domain and range, and then we graphed inverse sine, and remember it's a function, so it has to be defined or had to have a restricted range for it to be a function. We dashed the part that we did not need, and then we kept the part in solid line for the part that makes it a function, and its domain is -1 to 1. Its restricted range ended up being -pi over 2 to pi over 2. And then we realized that sine is also odd because inverse sine is odd because inverse sine of -x is negative inverse sine of x. And then we evaluated some of these values, which are here. You can see numbers 1 through 3. And also finally concluded that the sine of sine inverse is x for all x between -1 and 1 inclusive, and the inverse sine of x is x equivalent because of the restricted range for all the x's between -pi over 2 and pi over 2 inclusive. So now moving on, we're going to graph inverse cosine. Okay, the procedure is pretty much the same. So remember, keep in mind that cosine is, we're going to start with cosine and then inverse cosine. Keep in mind that cosine is even. So here we're going to say, reminder, cosine of -x is equal to cosine of x, and it's even. And then when we're graphing, the domain for cosine is -infinity to infinity, and the range is -1 to 1. And the graph goes here at -pi over 2, we have a 0. At -3 pi over 2, we have a 0. At -2 pi, we go back up to 1, and so on and so forth. Those are your parent points. 0, 1, pi over 2 back down to 0, pi -1, back up to 0, and back up at 2 pi at 1. So we're going to have a graph that looks something like this. Make sure when you're graphing, your concavities are clear. So if you're going through a 0, that's your inflection point, versus if you're going back up to a maximum or going down a minimum, the concavities must be well defined. Those are not flat. Okay, and that's important when graphing. Now, so again, now we're going to inverse cosine. Let me change the color here for inverse cosine of x. The domain, the range becomes a domain, so the domain now is -1 to 1, whereas the domain becomes the restricted range. And when we're graphing inverse cosine, let me first graph it, then dash it, okay? So your graph is going to be, remember here, up is pi, 2 pi, and down is -pi, -2 pi. So you're going to go 2 pi, here 1, and then back to 0 here. Actually, it's going to be 0 here, -1, back up, 0, pi -1. So your graph is going to look something like this. And again, this is not the finalized graph. Notice how it takes me a few attempts really with my pen to Okay, so if I keep it in this format, this is not a function. So I have to restrict it. And because of that, I'm going to restrict it between 0 and pi, which is right here. Okay? So what I'll do, I'll try to dash. Let's see if I can hopefully dash the rest of it. Let me dash it all, and then I'll. Okay, so I'm going to dash it all, and then I'll make this part between 0 and pi solid. Okay. So it is a function on this restricted range of what? Of 0 to pi. Okay. Now, note that if you do cosine inverse of -theta, that is not equal to cosine inverse of theta. And also cosine inverse of of negative theta is not equal to negative cosine of inverse of theta. So it's not even, and it's not odd. Okay, so there are no symmetries. The symmetries that we usually have, they're not existent for inverse cosine. So it's not even and not odd, because we may assume that because cosine is even, therefore inverse cosine is even. That's not necessarily true. In this case, it's actually not true. So now evaluate. I'm going to start with the end here because we already did this for sine and inverse sine. So I'm going to start with the end, where I'm going to start with this table and then go back and fill out some of the values. So for cosine of cosine inverse, that's x for all x, for x in between what? -1 and 1. And for cosine inverse of cosine is x equivalent. And now here for x is between what? 0 and pi. And with this said, anytime you see cosine of cosine inverse, the answer is just the value in the parenthesis. So you can automatically, like here, that's cosine, cosine inverse, cosine, cosine inverse, right? Both of these are going to be just the value. Just this is going to be, number 2 is going to be square root of 3 over 2, and this will be negative square root of 3 over 2. Now for cosine inverse of 1/2, and remember you're operating between 0 and pi. So this is going to be pi over 3, and that's where the trig values, or the knowledge of trig values helps. Cosine inverse of -1/2, that's 2 pi over 3. For number 3, cosine inverse of cosine of pi over 4, that's just pi over 4, because pi over 4 is between 0 and pi. And cosine inverse of cosine, so this here, if you think about it, this here is a square root of 2 over 2, right? And then cosine inverse of that is going to be what? Is going to be just pi over 4. This is really use quadrant 1. Okay? And then cosine inverse of cosine of 3 pi over 4 is 3 pi over 4, because remember 3 pi over 4 is an element of what? Of 0 to pi. It's less than pi. It's 3/4 of pi. And then cosine, now here be careful. 5 pi over 4 is not between 0 and pi. So here I'm going to say 5 pi over 4, right, is an element of what? Or is in quadrant 3. So what's the equivalent for it? You see, we said x equivalent. What's the equivalent that would give you the same value? The equivalent angle, I should say the equivalent angle, just to be clear, is what? Is 3 pi over 4. So this answer is going to be 3 pi over 4. Okay, and that's what we mean by x equivalent. Okay, if you're not here, if you're not between 0 and pi, then we have to find the angle that is equivalent to that angle that is not between 0 and pi. That would give you the same value here. So this is how cosine inverse works. For inverse tangent, again, same idea. Now here it looks like, so the period here is pi for tangent, right? So we're going to start with tangent as usual, and then do inverse. Here the period is pi, so from -2 pi to 2 pi, that's 4 periods actually. Okay, and we're going to be careful here, halfway. So we're going to be careful where asymptotes are. And so those are really, they should have been dashed lines actually, but it's okay. I like to keep the dashed for asymptotes and the dotted for the actual virtual ones, even though they're both virtual, but normally dashed are for asymptotes and dotted are for the really non-existent. Okay, so this is x equals -3 pi over 2, x equals -pi over 2, and so on. And tangent is going to be asymptotic. Now here, just be careful also. So one way to graph tangent is going to look something like this. Okay, and you can copy paste this or on your end you probably need to actually graph it. So just a couple things here. Again, make sure the concavity is correct, and make sure that the graph gets actually close asymptotically to these dashed lines, okay? So that's important. And here, it looks more like this on this end, right? And on this end here, it looks coming from below. So you can see 3 full and half, so 4 total. Now, what is the domain for tangent? The domain is negative pi over 2 plus k pi, comma pi over 2 plus k pi. That means where k is an integer, so for all k and z. And the range is negative infinity to infinity. Now, for inverse tan, so arctan, the domain becomes negative infinity to infinity. The restricted range, remember we're going to operate in one full period where it's basically a function, so I'm going to just take negative pi over 2 to pi over 2. Now, the graph is going to also look very similar here. So please practice graphing and graphing accurately. And also remember, up is positive, down is negative here, right? So this is x equals 3 pi over 2 on the top, and then x equals pi over 2, and then here negative pi over 2 and negative 3 pi over 2. Okay, and your graph is going to look something like this. That's on one period. Okay, and you're gonna do the same thing, but you're gonna dash it. So all these I'm about to graph, all those are gonna be dashed. So this will be dashed basically, or dotted in this case. Okay, you can dash it, it's fine, as long as it's not a full solid graph. And then same here. And please extend your graphs so they look like they're asymptotic. Okay, so try to extend them, don't make them short. And this is super important basically for us to do. You see how I extend them asymptotically to very adjacent to these asymptotes. And make sure you take your time graphing. And then one last piece, which is gonna be pretty much here. And again, even if it's half, quote unquote, half of a graph, then make sure you have arrows, accordingly. And this is pretty much inverse tan. So again, make sure, keep in mind our restricted range. Previously, we had a restricted range for inverse cosine, and before that, we also have a restricted range for inverse sine. So inverse sine, inverse cosine, and inverse tangent, they all have restricted ranges. Now, some evaluation. Before the evaluation, we can jump automatically to the conclusion. Tan of tan inverse is just x for all x. And then here, tan inverse of tan is x equivalent for x, an element of negative pi over 2. Be careful, we cannot include negative pi over 2 and pi over 2. So those are exclusive. So again, anytime you see tan of tan inverse, the answer is just what's in the parenthesis. So for instance, for number 2, the answer is square root of 3. Here it's negative root 3. For the first question, tan inverse of 1, that's pi over 4. That's between negative pi over 2 and pi over 2. Tan inverse of negative 1, That's the negative tan inverse of 1. And by the way, speaking of that, tan inverse is odd. Tan inverse of negative x equals negative tan inverse of x. So for number 1, the second one, negative tan, which is going to be negative pi over 4. Number 3, tan inverse of tan of pi over 6. That's just pi over 6. That's between negative pi over 2 and pi over 2. Tan inverse of tan of negative pi over 6, that's also negative pi over 6. Now 5 pi over 6, that's problematic. So that's not there. That's not between negative pi over 2 and pi over 2. So we're going to find the equivalent, and that's going to be negative pi over 6. And here, same thing, 7 pi over 6. Tan inverse of tan of 7 pi over 6 is actually just pi over 6. Okay, so these are not too bad. Let's try some. And the ones here, tan inverse of cosine of pi. We know cosine of pi is negative 1. Tan inverse of that, we just did that, I believe, is negative pi over 4. Cosine, so when you see tan inverse, that's easy. When you see cosine, when you see the actual, like cosine, you want angles, right? So you want the triangle. So hint, draw a triangle, so I'm going to draw a triangle. I want tan inverse of 3 over 4. That means opposite. Remember, tangent is opposite over, so this is opposite over adjacent. So opposite is 3, adjacent is 4. The right angle is here, and this is theta, which means the hypotenuse is 5. So this is tan inverse of, this is theta. So cosine of theta, that's adjacent over hypotenuse, which is 4/5. This here is equal to 4/5. Okay, same idea, sine of cosine inverse, draw a triangle. So your triangle is going to have, remember, cosine is adjacent over hypotenuse. So your adjacent is 3, and hypotenuse is 7. It's going to be up here somewhere. This is 7, this is 3. This is your angle theta. So you're going to do 7 squared minus 3 squared. So 49 minus 9, which is 40. This is going to be square root of 40, aka 2 root 10. Let me clean this up, 2 root 10. So this is your angle theta. So sine of that, that's opposite over hypotenuse, which is going to be 2 root 10 over 7. So you're going to say sine of all this is equal to what? 2 root 10 over 7. Okay? So that's not too bad. Tangent of, again, same thing, draw a triangle. This is your angle theta. You want x over 1, right? That's opposite over hypotenuse. So opposite is x, hypotenuse is 1. This means this side here, the adjacent is 1 minus x squared, square root of 1 minus x squared. And note that x is between negative 1 and 1 here, right? In fact, here, in this case, if it's up, it's going to be positive. So tangent is opposite over adjacent, which is going to be just x over root of 1 minus x squared. And then lastly here, cosine of sine inverse, same thing. We're going to have, this is your theta, and this is negative 3x, which is negative 3x over 1. So when you draw a triangle, you're going to have the opposite. I mean, I would say negative 3x like this, even because I don't know if x is positive or negative, right? So it's fine. That means opposite is negative 3x, and hypotenuse is just 1, which makes this 1 minus, square root of 1 minus 9x squared. So cosine of that is adjacent, which is square root of 1 minus 9x squared over hypotenuse, which is 1. So it's just square root of 1 minus 9x squared. Okay? And notice here, hint, note, x is in between what? Negative 1/3 and 1/3 inclusive, because you want this to be greater than or equal to 0. Okay, so this is the first part. Now this second part is more of a summary, really. It's nothing new. And then graphing, which is new. So here, this part is domain and range for, this is a good summary. Domain for inverse sine is negative 1 to 1. Range is negative pi over 2 to pi over 2. The domain for inverse cosine is negative 1 to 1. Range is 0 to pi. And domain for inverse tangent is, negative infinity to infinity. and the range is negative pi over 2 open, 2 pi over 2 open. Okay, so keep these in mind. Now the second part is graphing. We will address that in the next video. I hope you enjoyed this video and you kind of solidify your understanding of graphing functions, specifically trig and inverse trigs.